dışında bu kadar. Direkt beni şey yapabilirsiniz, durdurabilirsiniz. Hızlı hızlı anlatıyor, bölmenin falan filan gibi kafaya girmenize gerek yok. First, I open KiCAD, as we all do, please. I definitely suggest you should also open KiCAD and do exact the steps that I do, because without that you wouldn't understand and you wouldn't learn how the program works. I click that new file. I make a new folder. I don't like have it. I say Bilkent workshop. If I go too fast, definitely tell it to me. I first click on schematic editor. Bam. This is our schematic. We're going to make everything here. Let me start with the presentation. You'll understand better. Okay. This is what we're going to make eventually. This powers the PCB. This is an IC that will use it to blink the LED, and this is the LED. These are just capacitors components that I'm going to explain and how they work. So, what is a PCB? Let's start from here. PCB is a printed circuit board. You make your circuits here, you prototype them, but eventually you want to put them in a product, inside a computer, inside like a fridge. So you cannot put a breadboard inside a product. So what do? You make a PCB. This is a PCB that I made also. I made a medical device. So this is the PCB for it. So they do come to life, the things that we design. Yeah. Okay. So yeah. Let me talk about some of the concepts. You're going to learn concepts. Without concepts, you didn't learn anything. Without the words for it, you don't know the thing. So this is a via. You put a hole through the layers. Oh, I need to explain layers. Okay, so layers. You have different types of layers in a PCB. You have the protector layer up top. You have the copper layer, top layer we call it. Then you have FR4, which is a dielectric layer that protects the other layers and doesn't allow like a capacitance between them unless you work really high frequencies and really high power. They might transfer. And you have another layer of copper. We call it bottom copper. And yeah. So layers are these. We call copper layers copper fields or copper zones. Okay. And we have on the copper zones we have power zones. So some zones that are specified for the power consumption, power delivery. We have vias, which are like holes that are connected in different layers of copper. We have traces, which are like wires. So yeah, you got the concepts. You can ask definitely if you didn't get them. So, for example, here, this would be a trace that we make through here, right? This is a trace, and this is the top copper plate, the whole thing. We have like 4 different layers. I'll show on KiCAD as well. Don't worry. This is the schematic that we're going to make. It looks complicated, I get it, but after you make it, it will become easy. And this is the layout that we are going to make eventually, all of us together. So, design flow. We are going to do 5 things. You can remember that all throughout this thing. Make the schematic, okay? Then we are going to check if the schematic is correct, the second step. We are going to assign footprint. So what is a footprint? It is what we are going to put on the PCB to solder. So you have a schematic, but what does it look like in real life? So the footprint is the thing that you put the component on. Yani solderladınız yani. Okay. Did you get it? And we do the PCB layout, we arrange the components, we wire them through, and then we do a design rule check, which is like electrical rule check. We check the PCB layout if it's correct, or if everything is correct, if everything's connected, if the distances manufacturable, etc. Okay. Bunları ileride yapacağız. You can go ahead with KiCAD. So here is the schematic. Schematic problem. Schematic problem. And we are going to start the schematic. So I click here at components, or I can click A directly. I type USB Type C, USB, and I click on USB-C receptacle. This is the first thing that I'm going to add on my PCB. We generally add the imported components first, and then we add the resistors, the other things, the other components. So we have two main components, the USB Type-C, the thing that you put here, the USB Type-C in, I forgot the name of it, and the NE555 it is a blinker IC, just, you don't need, I made the schematic part really easy for you to understand the KiCAD, so it's just a LED blinker thing. So I write NE555, I place it here as well. We can start. Okay. We can ignore it for now. Okay. So this is what a USB Type-C is. As you know, you can put it both ways. So we are going to make a connection 2 times. So a bottom side and a top side, which is mirrored and flipped. Yeah. Okay. So we don't need any of these for this project, but I will tell you what they are regardless, because you might use them on your projects. This is for USB second generation type of USB, the D ones. We are not going to use them, so I click on Q, which is not connect. I click on N first to set the grid. So if I want to use bigger grid to like draw things on, which we are going to do later, like this. But I'm going to use smaller thing, smaller grid with typing N. I press N. I come here, press Q, not connect, not connect, not connect. So these are USB third generation, which does really fast data transfer, faster data transfer, which is USB Type-C is known for. We don't connect these as well. Okay. And these buses, bus 1, bus 2, are used to tell the other parts of Type-C to send either audio files, video files. You can configure Type-C like that. We're not going to use them here as well. So shield is the protective layer around the Type-C receptacle. I am going to first click on P. This is power symbols. So power symbols are like grounds, 5 volts, which is the things that power your PCB. So we want to label them separately. I click on P. I type ground. I get the global ground. I use generally global ground. You don't need to do much more than that. Generally, I connect ground and shield together. Yep. And yeah, we almost done with the receptacle. I am going to now tell you how does USB Type-C determines which type of device you are. So this CC1 and CC2, if they are connected to ground, you are a sink. If these are connected to your VCC, which is the powering source, this is the powering device. So I want to charge my phone using my computer. My computer has these ports that are connected to the VCC, but my phone has the port that is connected to the ground. Okay, so it tells you these are not for powering it. These are for telling the other device, please send me electricity, I want it. Or telling the other device, I am going to send you electricity if you want it. Okay? So I use pull-down resistors. A pull-down resistor is just a resistor between ground. Okay? You don't need to know more of that. I click on A again. Does everyone follow? You just stop me if you can. Or if you have a question, just straight up. Ha.
Şu parçaları koymayı tekrar göstereyim.
Aynen. Ya da şuna basıyorum. Bak şuna.
Sağdaki tahtada var.
Hiç hoş değil. Deseniz oğlum başta. it's here. You click here or you press A. Okay. You add USB Type-C receptacle and then you add NE555 and then you're done. Yes?
Şu ground'u nasıl bağladık? Hangi tuşla?
Ha, I pressed P ya da şurada da bu var. Add power.
Tamam.
Or I click P, okay? You guys have any other question? Just stop me. Valla. I'm not like a teacher. I'm one of you guys.
Yok ground'u koydum da A1'e S1'e nasıl?
Onu söylemedim. I come here. I press W to add a wire. Or I click here. Yes, which adds a wire. Okay? Or I can straight up click on the thing, which doesn't, yeah, I just click on the thing and wire it directly. That is three ways. Okay? Any other questions that I might skip? Yes, you can say I forgot something. Şu mu? Bu bir IC, dip IC'lerden biri. IC'de
Neydi ya? Ice'ın olduğunu biliyorum.
ha, bilmem ne olur o yüzden.
Parçanın adı ne?
NE555 NE555. It is used to blink the LED. We are going to configure it so that it could send us a pulse width modulation signal. So we would use that to power the LED, right? Did you guys click on the QR, right? For the G205, Yes. If everybody is caught up, I'm going to continue. Okay, Marlon? Got it? Cool. I am going to put pull down resistors, and by that, I am going to press A. Then I type R to find the resistor. I click here, bam. Now I have a resistor. And then I click on R again to rotate it. Okay? I take it, I click on it to copy it and paste it again because I'm going to use two of them. As I said, this is a Type-C device, so we need two of each connection. As you can see, D-2, there is two of them. CC1, CC2, there is two of them. So we are going to connect things twice. I come here, I press on P again. I come to ground. Bam, I put it here. I put it here as well. And then I connect these two, just like that. Now, I'm going to click on register to change their values. So this is like just green thing comes to you. This is called production. And after the production, there is assembly part. You might want the company that that is sending your PCB to put the components on and solder them so that you wouldn't have to do it. This is assembly. The values on it are helpful for the engineers that are going to look at your schematic. Okay, they are important for the people that are going to solder your components on the PCB. Yeah, these two. So we use conventional designs and we try to annotate our schematics as much as we can. So that's why we put 5K1, which is what the value, like we put the values for the people that are going to solder on the PCB. And we are going to do VBus right now. Okay, I am going to use, is everybody got what I'm saying until now? I click on the part, okay? There was R, a letter R on it. I click on R, and I get the value window. I click on that. I write 5K1 on it, and then I just press enter or OK. Okay. Is there any other questions I can answer? Is everybody got it? Okay, we are going to continue with the other ones. Okay, as you can see, there is a faulty connection. I saw it like this is supposed to be. This is what it's supposed to look like when you get a proper connection. This is not a proper connection. I delete it. Like that. I look at it. Bam. I fix it. That was a good mistake, so you can see it. Okay, I'm going to add two more components. One is a fuse, and the other is a TVS diode. Okay, What they are, I'm going to explain them first, and then I can show them later. I'll show them in schematic. So, I'm going to add a polyfuse, which is a fuse. I'll just explain what a fuse is first. If you get a large current that are larger than the polyfuse rating, larger than a fuse's rating, the fuse just shuts itself. Sigorta in Turkish. Okay? And a DTVS diode is the same thing as a fuse, but it is used for, not structurally the same thing, but conceptually the same thing, but it is used for voltage. If your voltage gets really high, your DTVS gets rid of it. You can think, if your current increases too much, this resistance becomes infinite, so this is an open circuit. This is what a fuse is. And DTVS is, if your voltage gets really high, all of a sudden, like a lightning, or you plugging in the USB Type-C, DTVS becomes a short circuit, and when there is a lot of voltage, this becomes a short circuit, and that high voltage goes to the ground without hurting your ICs. So these two components are important if you are going to make like high power applications, if you are going to power things with a USB Type-C that like we are doing right now. So these are important for the design. Okay, I come here. Yes.
DTVS Türkçesi ne?
Diode, TVS diode mu?
Transient voltage suppression neydi?
Ben açılımını bilmiyorum aynen.
Transient voltage suppression diode diye geçiyor.
Koymuş. Peki. I come here. So, I write polyfuse. Niye böyle gözüküyorsun? Ha. I add it like this. I select, if I want to move things like this, I select all of them and just straight up. Like it's like what you would expect. And I come to the, I click here. I connect it like this, and I press on P again. I add another ground. Yes, I add another ground like this, and I connected that. I click on P, and then I type 5. Niye böyle gözüküyor? I click on 5, and then I pick 5 volts and add it to the schematic like this, and then I wire it through here. This tells the schematic, the ERC, the electrical rule check, to that this is a power pin. Okay, this is just a label. Yeah. We are going to do that. I forgot for these names. I'll add the components later. I'll just show you the schematic of the other one. These are specific parts that I sort of like. So I'm just saying. So we are done with the power part. I just click on this square thingy. I come here. I make my grid larger by clicking on N and coming to 2.45. And adding my square like this. This is for labeling and compartmentalization, and this makes your schematic really easy to read. I come here, I make this larger, I make it bold, and I say power. And I add bam. You just labeled a schematic like an engineer. Congrats.
Can you say one more time? How did you make grid bigger and
Yes, okay. I click on N. Ne harfi.
Ne? Okay.
Ni'de. Night. Yok, night'ta değil. Neyle bir şey söyle. Yeah, that's it. And I click on this rectangle thing. I add the square like this, and I click on text. I make the text size 2, which is large, and I click on bold. I write power here, and then add the text here. Okay? Any other questions? Hızlı gittim ben. Okay. We can carry on with the rest of the schematic. Okay. Now we are going to make the blinker stage. I'm not going to explain how the IC works or how to set the resistors themselves. Its data sheet tells it to you. Maybe I can show the math on the data sheet. But I calculated the resistors myself, the capacitor myself. So it sends away 5 seconds up, 5 seconds ground. 5 seconds 5 volts, 5 seconds ground, okay? So I start. I first add the power. I come here, 5 volts. Bam, place it here. I come to the ground, I add the ground here, right there, okay? And I forgot to do the labelings. Okay, so when we are making the schematic, we want to label the wires themselves. Because when we are going to wire in the PCB section, it will be really hard to find the sections that are correct and click on the right ones. So I click on L. I write pull down 1 for this one.
Nasıl power diye label
Ha, I click on P or I click here.
Here var. Okay.
Gözüküyor değil mi? Okay. I click on here or I click on P, the letter P. Yeah. Please do stop me like this if you have any questions or like you're stuck. I click on L again. I write pull down 2. I click on the wire themselves to label the thing. And where did I? Bu da şey. Poly here. And I label the polyfuse itself as this, like that. And we don't need to label here because this is 5 volts, this is ground, we don't need to label those. This is ground, we don't need to label those. Bam, this is done. But you need to label the wires so you wouldn't get mixed up when you're designing. Like you're deciding on the PCB layout and wiring themselves. We can start on the thing right now. I wire them like this. This 8 pin is the VCC. This is the ground. I put the reset pin to here. I do this curving thing by doing. Click on W. Click on mouse 1. Click on mouse 1, so I can snake around like this. Okay? I'm not going to connect here, so I'm going to press Q, not connecting. Okay? I'm going to make a wire here, like this, and I'm going to press double click to just finish the wire unconnected. I press label, I label it C3, bam, I'm going to connect it to somewhere else now. Later on, this is okay. I'm going to add another power. 5 volts. I add it here. I add my first resistor. Bam. Then I add my second resistor. Here like this. And then I add my capacitor. I click on C. This C comes out. This is a capacitor. Bam. I place it there, and I put another ground. Connect it to here, here, here. Okay. So I'm going to do something here. I press on label. I write C3 again, and name this node C3. So C3 just connects this wire and this wire without physically connecting it, which is useful for this type of schematics. But if I could have done this, but I don't like doing it like this, bam, bam, bam. I don't like this type of connection. So I just use labels like this. And do you guys have any questions until now? I add components by clicking A, and then I type their names, C, R, and then using them, I add them here. Az önce şunu yaptım. I clicked on it, hold it, and drag it to change the position of it. It allows you to like change the places of components. So this is a useful information as well. I click it here, bam, bam. I drag it here, yeah. And I'm going to connect this here. And I'm going to label this. Link out. I don't use spaces because the DRC and ERC sometimes adds a problem when I use spaces, so I just add a işaretten ekliyorum. Bu neyse. I add this instead of a space, so be careful about that. I can click R to rotate it, as I told you before, so I rotate it so that it wouldn't touch anything. Yes. Blink out. This is the label. I'm going to now let's make these values as well. These are specific values to create a positive modulation signal with 1 Hz that is open, close, open, close. 5 seconds open, 5 seconds close. This works that. Okay. Am I missing anything? Do you guys have any questions? Yes. I come here on the side. Can you see it? And I click on it, and then I write 5 to get the 5 volt, or I write ground to get the ground. Now I'm going to explain another concept to you: decoupling capacitors. Okay. So, do you guys know what a decoupling capacitor is? Does anyone know? Please. Okay. Do you know how we calculate impedances? How many of you guys are EE students? Maybe I'll go deeper on that. Okay. So, capacitors and inductors act like resistors when you move an oscillating signal through them. Okay. So, we want none of those signals, like oscillating signals, when we power our ICs and other things. We just want DC. We just want 5 volts, nothing else. No oscillating stuff. So we use capacitors to get rid of the oscillating things. So a capacitor would not allow the passage of a DC current, but it does allow the passages of AC currents. So we calculate which capacitors to use using this formula. Maybe it's complicated for you guys, I don't know. But in 1 kilohertz signal, a 1 kilohertz sinusoid, for example, a 10 microfarad capacitor acts like a 16 ohms. So, and if in 10 kilohertz, it acts like there is no almost capacitor. There is nothing. It just acts like a wire. You can think of like that. I connect a wire that only AC can pass, so it filters out. This is what a decoupling capacitor does. Also, it is a large capacitor, so it is charges through DC. Imagine your voltage drops for a second. Sometimes, like some voltage drops when you move things, or from the current itself, your voltage drops. The capacitors can provide the voltage that you require through discharging. So that is the reason we use decoupling capacitors. Okay. So I'm going to add decoupling capacitors right now. For this, I'm going to add the schematic here. I add one C, the other C here, and I add 5 volts. Start working. Making good time. I add ground connection. And I So I connect the decoupling capacitors across the power rails, which is like 5 volts and ground in this case, and I put the decoupling capacitors really close to the ICs when I do the layout. That is the reason like they're separate from when they're here. They are the decoupling capacitors. I am going to set one of them 100 microfarads and 10 microfarads like we calculated before. And I add another decoupling capacitor here. And it is 10 microfarads. Yeah. And I connect the ground. And I add 5 volts here and 5 volts here. I made a mistake here. So all your 5 volts, like all of the power pins, should be on the same level to like signify this is a convention. Do you guys know what a convention is? So it's not a rule among engineers, but all of us do the thing in the same way. So it's not hard for us to understand when we see it. Like the things I did here, I added labels here. I put it in a square. These are conventions. So I added do not connect here. These are conventions. They are not necessary for the design, but they make it for other engineers and for you as well to like remember the things and like understand the schematic really easily. I also suggest like if you have like let's say you make a filter. When you make a filter, I would suggest write its formula, like write its gain using a labeling here, like let's say AV is like 10 volt, 10 gain. You have a stage of 10 gain. You add it to here, like under the things that you're going to make. So make it conventional, okay? It will help you and other engineers really much. Neyse çok fazla yanıldık. I add other square. Click on here. Band 2. It is volt. I write the Blender stage. And I add this. Do you guys have any questions so far? We made the blinker stage.
How do you make the square?
Ah yes. Can you see the right part?
Yeah.
Thing? So I come to this box thing. I click on this is the button for adding a rectangle. I click on it, and I make my n higher. Come here, make the n higher, and add my square like that. Okay.
I don't have that button, I think.
Sure.
Aynen. Şey var mı klavyede?
There is no shortcut for it. I think so. Şey üstüne yazdım ben de bilmiyorum yani. Maybe you can use it like the lines for. You can use the lines here. Those are not lines. Those are lines for you.
Direkt şu T'nin altındaki kısım bende yok, farklı bir versiyon.
Maybe we can look at after the workshop. Okay. So, other questions? Do you guys have any other things?
Ya, ekran çözünürlüğüne göre aşağı kaymış olabilir.
Ha, doğru.
Görmesinden göre olarak.
Okay, I'm going to continue if you don't have any questions. Did you guys get decoupling capacitors? People uses the DTS diodes, pull-down resistors. Why we use power labels and global ground? Do not connect symbols, the conventions. Okay, you got it. I am going to add the LED now. I come here. I first add a resistor. I rotate it, clicking R. Then I add. This lighting thing there. Okay. I rotate it twice, and then I add another ground. Connect them.
Yeah, this is just a normal LED.
Yes, it's a normal LED. We are going to assign the footprints later. So a footprint is like what you decide. Is it a SMD component? Is it a TH component? TH means through hole. SMD means surface mount device. And I come and I connect the accounts here. Yes. I set the register value 1.5. So before we continue with assigning footprints, haklısın. Did you guys get it? I was able to resolve this time. Previous stage.
Sen koymadan nasıl döndürüyorsun?
I press R.
Ah,
Yes.
thank you.
Previous stage. This is the schematic. Congrats, you made the schematic. Now we are going to assign the footprints, and I'm just let you go early. And I like can answer your questions before it.
And by the way, how do you have a shortcut for mirroring components such that if they are asymmetric?
I think it was E. Let me see. Hiç hatırlamıyorum. Do you know? Söyle abi. Sen ne biliyorsun? Okay. Yes.
Web'de en son bağladığımız şey ne?
This name.
Yok.
Ne var?
Ha, tamam.
Sure. This is a LED. This is a resistor. Yes. And I'm going to add a label here as well. I'm missing a label here. I call this. This. I add a label here. Make sure that all of your wires are labeled. It will help you immensely when we are going to wire things tomorrow. Link out the not LED. And all of things are labeled. Do you have another questions? I'm going to find the values for these. And are you guys tired or do you want me to continue? I can, we are done with the schematic. I'm going to assign footprints as the next stage. İnge falan? Yok, daha İnge yetişemezsiniz. Devam edeceğiz. Assign footprints. Okay. I come here, I click on tools, here, tools, and I say assign footprints. Okay? And this window comes up. Yes. Okay? Sonrasında da. So, I'm going to explain some of the things. We have a section called packaging. So, packaging tells you which footprint to use. Footprint is the thing that, the part that you connect your component to the PCB, the part that you solder to. You can pick SMD components, TH components. We're going to place SMD components first. Şey var mıydı ben? Burada hangi şey var? So, for the capacitor, I click on it. I come from the list here to capacitors, SMD, okay? This is the place that we are going to assign the footprints. This is the list, the bigger list, and this is the smaller list, like this is the sub list of the footprints. This is the sub list, this is the main list. I click on SMD and come here to the sub list. Okay? I have different. Lütfen büyüsün. Yok. Keşke büyüse. Gerçekten. I'm sorry. So, different assembly components have different packaging. So, for the capacitors, you can have 603, 804, etc. If you are going to hand solder them, I suggest using 1206. This is like relatively large SMD component. There is no way you're going to solder as 0603 component. I'll show you online. 0603. There is no way you're going to solder that. You need a hot blowing solder iron, I think. That's called hot iron. Blowing iron. Huh? Aynen. I don't know the English method. Yeah, you need this to solder that. So instead, I suggest if you're going to hand solder them, use this type of packaging. Come here, SMD-C. I'm going to use capacitor tray, SMD C1206, 3216 metric pad, hand solder. Okay?
Yeah, what is the number?
Which one?
65.
1206. 1206. 1206 is the mils, like American measuring
Oh,
units.
okay.
Mils, yes. And it says the metric version right next to it, so it's like the measuring units of the. Yeah. It's all standard for the assembly components. It is the size of it, really. 1206 is large. 0603 is like smaller. Yeah. I suggest this one, and also hand solder. So it makes the pads larger. So what is a pad? It is the coppers that are visible to you. Yani şey var, solder mask var. Solder mask yeşil şey üzerindeki. Tamam mı? Yalıtkan gibi düşünün. Yalıtkanın altında copper filiniz var. O da şey bayağı iletken kısmı. Padler solder mask olmayan copper kısımlar. Sen oraya şey yapabilesin diye. Solder kullanabilesin diye. Yes. Yeah, copper pads are those. I pick the same for all capacitors.
Bunların işe yaramıyor.
Durun. Hey, I am sorry. We need to do some other convention. I am so sorry. We are going to change the name of the resistors because it goes from left to right, increasing, and up to down, increasing. So you cannot have like C1 here. No, you're supposed to have C1, C2. You got it? So I changed the name of it. Böyle olmaz. C1. I changed the name of it. C2. I changed the name of this to C3. I changed the name of it to C4. Okay. Ana iki bölüm yapıyorum. Bakayım. A1, A2, A3, yes, A4. Yes. Now we are conventional. I come to tools, assign footprints, we continue with this. Yes, siz gördünüz mü? Benim değiştirdim. It's important, the convention. I click on capacitor, click on Control C, and click on another capacitor that I'm going to label. I then I click on Control V. I just copy paste it then for these. Okay. For the DTVS diode, online I search a component that I'm going to use. I look at the packaging and I select the footprint that is appropriate for that packaging. And if there is no footprint assignable on the KiCAD, you need to import it from internet. I'm not going to show it here. Sorry, it might take a little time. So I click on the DTVS diode. I come to diode, SMD diode, SMD. SMD D-Sol 123. D-Sol, yes. 133, 123. This is the thing, this is the footprint that we're going to use. And for the LED, I click on LED here. I come to here. LED, THD. I am going to use a through-hole component. Through-hole is like, it goes through the PCB. SMD sits on top of the PCB. I click on THD. Analiz bir şey olursa direkt gördüm. Gördüm ben. Yes.
Prints. Ne oluyor tam olarak?
Ha, footprints şey böyle. Did you understand pads? Pads. P-A-D'nin olduğunu anladın mı? Pads. Okay. So, I show it from here. Yes. On top of the PCB, I have a solder mask layer. Okay. Okay. And under that is the copper layer, copper film, and the visible part are pads. The copper visible parts are pads. So when you are going to solder a component, you want that component to be like exact measure. You want to know the exact measures, the height of it, the length of it. That's the footprint. The pads are the parts that we soldered to it. Şeyde göstermiştim ya. This is the schematic. These are the footprint and the PCB. This is the footprint of the USB Type-C receptacle. This is a resistor, for example. This is the polyfuse. This is the DTVS, for example. Yeah, this is the footprint. This is the IC, for example, DIP 8. You definitely used DIP 8 if you are taking the. It's the type of package. It goes through the PCB. Yeah, this is what the footprint is. And I go to LEDs, THD. This is LED D3 mm. LED 3 mm. Yes, this. And I come to polyfuse. I come to fuses. This is a straight process. Like you do this each time.
Can you say the last name?
LED mi? LED D3 millimeters. Yes. If you guys get all of it, you can ask. It is not easy to see here.
Is it diode?
Huh?
Is it diode? Can you say
Which one? The DTVS or LED?
E1? ETV?
DTVS. Okay. It is D sod 1, 2, 3. Yes. Yani bu sonrasında da polyfuse, I come to fuses. 126, 1206. 2, 3, hand solder. I click to hand solder. Bu çalışmıyor değil mi? I normally click on hand solder, but in my version it doesn't show a footprint. So we're going to use schematic. It is the same. When you have a hand solder footprint, it is just makes the pads larger so that you can use your soldering item on it. So it makes it easier. I come to USB second. DC. Okay. USB. I come to USB here. It's in connector. Connector, and from the connector I find USB. Yes, here. USB-C receptacle. GCT USB 4085. Yes. This is the footprint that I'm going to use. And for the resistors, I'm going to pick one and go with the other ones as well. R1. I come to resistors here. SMD, as always. I'm going to use SMD components for all of it, except LED and the receptacle and the main IC. And resistor SMD R1206. SMD R1206. 3-to-1 metric pad hand solder. And I'm going to copy it and paste it across all of the resistors. Yes. And this is the fun part. You are done with the schematic. Thank you. Yani, congratulations.